Alright, welcome. This is part 2 of 2 in my protocol for contractility analysis in tissue. You'll need two things to do this next part of the analysis. The first is this file, which I'm calling a template Excel file, opened. And the second thing is the data that MYOCYTER outputs. So first, in this template file, go ahead and save a copy of it so that way you preserve the original template file for future analysis. And then I'm going to go in and open the data collected in part 1 of this protocol explanation. I'm going to open that in Excel using this from text feature. And in this directory, I'm going to go to where I saved the contractility data output from part 1 of this explanation. So first, I actually did 2 runs because I like to compare. I think these contractility results are more meaningful when compared to some sort of initial value to normalize it. So I have some contractility before the treatment, and then I have contractility values for 7 days after the treatment. So first I'll load in the values for before the treatment. And then here, what you want to click is the amplitudes text file. Buried within multiple folders of the MYOCYTER output, you'll find 2 text files. One is labeled amplitudes, one is results. I've saved both to my personal computer, but I think I'm only ever going to use the one labeled amplitudes. It's a bit of a misnomer because, as far as I can tell, this is essentially just position data, not amplitude data. It might be called amplitude just because I think there might be some processing to make sure it's positive values, not negative values. But at any rate, this is the data you'll want to load in, and Excel will load that into a new sheet. It correctly detects that this text file is delimited by the comma, so I'll just leave it at that, click load. All right, so it loads that into a new sheet. Now to get it into the sheet for the analysis, which is this sheet that I've already labeled initial, what you want to do, and you want to do this because this way it'll produce, nice graphs immediately once you copy and paste the table in, is you'll want to delete this entire table. So Control-Shift down, Control-Shift right. Then I'm going to press the delete key on my keyboard, click yes. That deletes everything. So you see this graph is just showing zeros now. It'll stop showing that once I paste in the data that we uploaded, which is currently in this sheet. So I'm going to paste that in, Control-Shift down, Control-Shift right, Control-C, and then Control-V here. And then you'll see how this graph here automatically updated to include the new data. So if I can show that here. So if I double click this, it's including all that data for whatever the first video was. You have to change the name here for only the first video, but it recognizes the name correctly for all subsequent ones in this template. Okay, you'll notice this currently isn't displaying a number. That's because what you have to do is go in here. The way that it imports the data is that it doesn't get rid of this parentheses and semicolon at the end, so you just have to get rid of that in the last cell. Right. And then now this formula and other formulas are yielding results. So this is looking good so far. I'll proceed with analyzing this later, but first I'm just going to load in the other data, so you can delete this sheet. Don't need it anymore. And just load in the data for the final. And just to clarify, the reason I'm not using the results sheet is because we're doing this. This process in Excel I have higher confidence in. This is something that you have a good deal of control over, using it by yourself in a spreadsheet in Excel, not relying on whatever sort of threshold values you inputted into MYOCYTER and whatever MYOCYTER is doing internally automatically behind in that sort of black box. So removing the black box, getting full insight into how to analyze these data. So same thing here. I'm going to paste in the new data. Correct the name again. Delete the ending again. Yeah, and you might notice that this Excel template is set up to handle 12 videos. You might have more videos than this. I think if you're using a computer with 16 gigabytes of RAM to run MYOCYTER, you can analyze up to 15 or 16 videos at a time. In that case, you might just need to remake the template. But for all the runs I've been doing, this has been sufficient. So that's just why I made the template like this. It's built to handle those 14 conditions. And so in this particular experiment, I didn't actually have 14 conditions. I had 12, so I'll just delete these final two that are just going to read 0 right now. Right. All right, great. So that's one thing you might potentially want to change in the original template. Another thing you might want to change to adapt to your use is that the way I've gotten the data from MYOCYTER is that I've chosen a reference frame, and I've chosen that reference frame to be contraction. Now, this for your case might be different. I think if you let MYOCYTER do it automatically, it'll likely choose a relaxation reference frame, in which case you might want to change all of this value of true to false in your version of the template. But this is what I did, and this is what I recommend in part 1 for analyzing the tissue using MYOCYTER. So this is what I'll leave it at here. And for these videos, I took them at 10 frames per second. And just, I guess, one note on the video collection, I think ideally you'd want to do it on similar settings. So you'd want, what I tried to do for the video collections, I tried to adjust the intensity value so that the tissue looks pretty much just as bright, and there's a decent amount of difference between the tissue and the surrounding. That contrast is similar. And otherwise, all the video parameters, such as the number of frames and so on, were the same. Not sure if that tissue brightness / contrast matters in the initial video, but that's just something I did, so I wanted to mention that. Yeah, all of the videos I've taken here are 10 frames per second, and so the delta t here is 0.1 for this and all other videos. These other parameters, so this is, I guess you could call this one parameter and another parameter. The third and fourth parameters I typically adjust for at least a couple videos out of, if I'm analyzing 10 videos, I might need to adjust these, in half of them. These are pretty good values, but not perfect. So I think they're good values probably for analyzing this particular video. And the reason I say that is because because of two things. Looking at the peaks here, if you count them, there will be 44 peaks. The thing to understand about this graph is that on the ordinate, the y-axis, it's speed, and on the x-axis, it's time in seconds. The speed is just in arbitrary units per second. And so looking at my sheet here, it's this column, which I've taken from the data that MYOCYTER outputted here. And then using the delta t equals 0.1, I made a sheet here, which, if you want, you could make it like this, right? Plus this. And then you'd go down like that. But, I've just since copied it over, just copied the values over. So that's how that timesheet was made. And then the speed, I just calculated from the prior values of the amplitude. So speed is a change in position. So this is position 1, position 2, over the change in time 1, time 2. Perhaps maybe more precisely, the time point associated with the speed would be at 0.05 seconds, somewhere in between, since I'm taking, these two speed values. But I think it doesn't end up mattering too much which time point you associate the speed at. And yeah, since it's speed, I took the absolute value of it, right? Because what we care about is speed. And later, I actually distinguish between whether it's a contraction or relaxation, using the direction of that, using the velocity. But anyway, what I was trying to get to before that explanation was these two parameter values and why you might change them. So looking at this graph, it looks like these parameter values are good. The reason I say that is if you count these peaks, you can count them from, I'm not going to count them now, there are 44 of them. So that's one way you can tell if it's good, is if there are 44 peaks showing. Another way you can tell if this is good parameter values is that if this contraction question mark column oscillates between contraction, relaxation, which of course is what your beating tissue would be doing. So if you see just a string of yes, no, yes, no, yes, no, yes, no, that means your parameter values are good. Here, because the template file only went so far down in terms of calculating this, I'll need to drag this down here. And I'll need to drag this down here. And then for this column, what this is doing is it's calculating the beats per minute. So it's looking at the first peak and the third peak, and the time between those, and the time between the third peak and the fifth peak, and so on, and calculating BPM from that. This is looking at the time between the max contraction speed and the max relaxation speed, i.e. the time between the contraction peak and the relaxation peak. And this is just gives the speed. If there's a y next to this, then then you would want this cell to be highlighted here because it's contraction speed, and then relaxation speed. If there's an n next to this, you'd want the cell to be highlighted here because this column should be relaxation speed. So I'll drag these down. Make sure you leave this space when dragging it down. And then you'll notice that this formula involves calculating a subsequent cell. So since there is no subsequent cell, we'll just delete that. Okay, and then here, these are the average and standard deviation of that. This is the thing that will ultimately become a data point on like a publication figure. So here, this is calculated as the average of that column, standard deviation of that column, and so on for all the other ones. So what you can see here is, which is pretty typical for what I'm doing, we got a speed around 10 initially, and a time between peaks of about 0.5 initially. This beats per minute is actually rather high from what I've seen, but definitely reasonable. So let's try to go on to something that might be harder to analyze. So typically post-treatment, they can get to be harder to analyze because I'm doing stuff that might make the tissue less healthy. This one post-treatment actually looks pretty good to me. Looks pretty similar. Let me just copy and paste like that. And sometimes one thing to notice here is that sometimes there's going to be an odd number of peaks, in which case I'll go back just to show what I did. The interval, which whenever it's calculating something that isn't there, you should basically delete it. That's the rule. So just check at the bottom of this list. It most commonly happens in the beats per minute column, but it can also happen in the other columns, right? So just check that you're doing that correctly. All right. Yeah, the point of this was to look at something a bit worse. So this looks kind of promising. So I typically write when the beating looks worse. So this I've written here. You can see rating 3 of 4. And indeed, it looks worse. So we're going to analyze this. This is going to be harder to not analyze, somewhat expected because since that I already noted the beating was worse. And in case you're curious, it could get worse than this. This is a rating of 3 of 4, right? And you're seeing, you're still seeing some peaks that are like, rather significant, like, above 2 or 3. In fact, a lot of these are above 2 or 3 arbitrary units per second. But if I can find one here with an even lower rating, there's also a rating of, yeah, these are both low ratings. Yeah. Yeah, so here's both of these are a rating of 1, right? And this is all just noise. Like all the things here that are like less than 1 arbitrary unit per second is all just noise. Maybe something here or here, it's picking up, like an individual cell that I found moving, because I did give it a rating of 1, so there's something moving in the field of view. But when it's kind of crazy like this and jumbled, I mean, this is data that I always just process like this, where I just I just zero this out. And yeah, we can get rid of all of this not needed. But for data, like this, or even like this, where there should be something, because I did see faint beating, then it's worth it to process it more. So going into this here, I'll finally explain these parameter values and how they can be useful. So what this means is that the speed value, the AU per second value here, needs to be at least 5 for it to be counted as a peak. So this peak is less than 5, so it's not counted. So this peak is the only one that's counted. And so what my formulas are doing is they're identifying one peak, and they're just kind of reporting that and that corresponding speed value. But there are more peaks than this, right? I think clearly above the noise, in my opinion, are peaks here, 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 and so on. And we'll get into analyzing the more difficult case, which is this one. And so I'm going to set it, I think the noise is kind of down here. So I'll set it at, maybe, I don't know, maybe 1. Let's start with a setting of 1 here. And you can see that changed drastically. So when we said the peak has to be at least a value of 1, there are now 33 peaks identified instead of 1. And so going through that here, so that was this column basically. So what this column is doing is it's taking this parameter value into account as well as other parameter values, which I'll explain now. So I'll go over that. So here, for example, it's looking at this speed value for this time point, and it's checking whether it's a peak. So the first check it does is whether the speed value is higher than the prior one. Looks like it is, so it passes that check, but it needs to pass 3 checks. And the second check, it doesn't pass because the speed value needs to be higher than the subsequent speed value. So that's not a peak. Same for the next one. And then if we look at this one, this speed value is higher than the prior one and also higher than the subsequent one. So it passes those 2 first checks, and then it also needs to pass the check of whatever this parameter value is. I'm setting it at 1, and it's greater than 1, so it also passes that one. So it returns a value of 1. And the reason I'm having it return a value of 1 is because I want to count all of these up. So this formula sums all of them to give the number of peaks, so it gives 33 peaks. And then here it just creates a list of that. And then here it's giving the time each of those peaks occur. I'm not going to go into this formula, but that's what it's doing. And then with this here is a second check whether it's a peak or not. And so here, if you look at this, what it's doing is it's taking the difference between this time and the prior time and checking whether it's higher than this value. And if it is higher, that means it's not a peak. So it's going to return a value of 1. And so here is the threshold value that I found to be in general good for analyzing this, about 0.3 seconds between peaks. Typically gives good results. You can see though that it's not giving great results here. And this is even without, going into the graph too much. You can see that because of this column. I guess before I go into that though, I'll just say that, so it identified 5 time points that did not pass this check. So it's only going to list 28 peaks, and it's going to give this time and, importantly, the speed for those peaks. And then what I do here, which I think is quite helpful for the analysis, is identify whether the speed, the velocity was positive or negative, and correspond that using this information, the reference frame information, to tell whether this is a relaxation or a contraction peak. And so just the way I've set this up, anything other than true is interpreted as false. So you can put, put false in here if you want it to look good. But if that is true, then it's going to take that into account in interpreting the velocity values. And if this cell is anything else, it's going to assume that your reference frame was not contraction, and so output the converse for this. But at any rate, one of the points of this, in addition to identifying this correctly, which it's not right now, we need to change that, but get to that later. But the point of that is that in this column, what you want to see is relaxation followed by contraction, and so on like that. It's not doing that, which means that some of these peaks are in fact not real peaks. So what you can do is you can try to change that. We're going to try to eliminate more peaks by increasing the value. So that eliminated a couple more peaks. Pretty good, but you can still see here, looks like here it's reporting 2 contraction peaks are following each other. That doesn't make any sense. So we're going to keep changing it. And I anticipated this being a hard one to change. So it looks like basically no matter what we do here, it's not going to be analyzing this in a way that actually makes sense with the data. So what you have to do is more time consuming, more manual, and is actually go into this. And one thing that's helpful here is to kind of identify how many peaks you think there are. And it's kind of hard with this, but I'll just say, I'll look at how many beats I think there are. So this seems like a beat. This seems like a beat. 1, 2, 3, 4, 5. Maybe something there, unsure, but 6 for sure here. 7. So 8-ish beats, I would say. So I'm just going to put the number of peaks I would kind of expect, which is like about 16. Might be a bit higher than that. Maybe it'll be more like 18, but we'll find out. And then kind of adjust this accordingly to start, just to give us something a bit better of a starting point. And then what we're going to do is go in and manually adjust whether these are not a peak. All right, so